This is a video from section 8.2 on zero and negative exponents. First of all, let's talk about zero exponents. Anything raised, any non-zero number or variable raised to the power of 0 will always equal 1. So x to the power of 0 is 1. The product AB to the power of 0 is 1. A negative number, a negative 87 raised to the power of 0 is 1. We'll explore more about why anything raised to the power of 0 is 1 in section 8.3. So right now you just need to know any non-zero number or variable raised to the power of 0 always equals 1. All right, let's talk about the tricky part of this section. When you are writing your expressions, you must always write your expressions with positive exponents. So you always have to simplify your negative exponents. To do that, we're going to use this rule, which looks very complicated. Anything like x to the power of negative n is equal to 1 over x to the power of positive n. So what I want you to notice is that I took the reciprocal of the power of x, and my exponent, once I took the reciprocal, became positive. That's important to note. So let me give you a numerical example. If I have 2 to the power of negative 3, I can write this with a positive exponent by taking the reciprocal of 2. And I'll write that as 1 over 2 to the power of positive 3. So when I take the reciprocal, my exponent becomes positive. I'm to the point now where I can simplify my exponents. So this is going to be 1 over 2 cubed, or 2 to the power of 3, which is 8. So to simplify this on a test or quiz, or on my homework, my answer will be 1 over 8, or 1/8. Now, if I have a problem that looks like this, 1 over 2 to the power of negative 2, you can see I have a fraction, but I also have a negative exponent. So to get rid of my negative exponent, I need to take the reciprocal of my fraction, just like I did in my first example. So to get rid of my negative 2 exponent, I would rewrite this as 2 to the power of positive 2 over 1. Now you guys are all good enough to know that I don't need the 1 in the denominator, but I put it there so you can see that I took the reciprocal of it. So 2 squared will be 4 when I simplify it. Now let's mix these properties that we learned in section 8.2 with the properties we learned in section 8.1. So my first example, you can see that I have a product of powers. So I have 4 to the power of negative 3 times 4 to the power of 3. Using my product of power properties, anytime I'm multiplying with the same base, I add my exponents. So this is going to give me 4 to the power of negative 3 plus 3 is 0. So 4 to the power of 0. Anytime I have 0 as an exponent, I need to simplify my answer. So anything to the power of 0, we have already stated, will be 1. All right, number 2. This is a power of a power. So in my power of a power property that I learned in section 8.1, anytime I'm raising a power to another power, I'm multiplying my exponents. So 5 to the power of negative 2 raised to the power of negative 3 can be rewritten as 5 to the power of 6. Again, we're to the point now where we can multiply out these powers. So 5 to the power of 6, if I type that in my calculator, should give me 15,625. Notice there was no need to do a reciprocal here because when I multiply negative 2 times negative 3, I get a positive exponent of 6. Number 3, this is an example of the power of a product property that we learned in section 8.1. So I'm essentially going to distribute the negative 3 to everything inside the set of parentheses. So I have 4 to the power of negative 3 and y to the power of negative 3. I cannot leave any answer with a 0 or negative number in the exponent. So with using the property that I just learned, I'm going to need to take the reciprocal. I'm going to take the reciprocal of anything that's being raised to a power that's negative. The reciprocal of 4 over 1 is 1/4. When I take that reciprocal, my exponent becomes positive. I'm going to do the same with y. Take the reciprocal of y. So I'm going to get 1 over y, and my exponent then becomes positive. Okay, using my multiplying fractions rules, I'm going to multiply straight across. So my final answer is going to be 1 over 64 y cubed. So my final answer is 1 over 64 y cubed. All right, our next example is similar to a problem that we talked about when we were talking about negative exponents. 1 over g to the power of negative 2. I have a negative exponent here that needs to become positive. In order to make that happen, I need to take the reciprocal of g. So 1 over g, the reciprocal, is g over 1, and my power becomes positive. So g squared is my final answer. All right, number 5. I have negative 8 to the power of 0. Anything to the power of 0 becomes 1, and I have a problem with my x because x is being raised to a negative exponent. So I need to take the reciprocal of x. That's going to become 1 over x. And then my exponent is going to be positive, so it's 1 over x squared. Using my rules of fractions, when I multiply straight across. So my final answer is 1 over x squared. All right. Number 6. Our problem is becoming a little bit more complicated here. We need to use the power of a product property from section 8.1, and we need to distribute the negative 1, the power of negative 1, to everything inside this set of parentheses. So I'm going to get 2 to the power of negative 1, m squared to the power of negative 1. That's a power of a power, so I multiply. That's going to give me negative 2, because 2 times negative 1 is negative 2. N to the power of negative 2 times negative 1 is going to give me a positive 2. So I'm taking a power of a power. In section 8.1, I learned I multiply my exponents. Okay, now I'm going to go to my denominator. 6 to the power of negative 1 is 6 to the power of negative 1. X to the power of negative 1 looks like this. And y to the 4th to the negative 1. Remember, when I'm doing a power of a power, I multiply my exponents. Now I have a problem here. Because I have negative exponents in my answer, everything needs to be written with a positive exponent. So I need to take the reciprocal of anything that's being raised to a negative exponent. What that means here is anything that's being raised to a negative exponent needs to flip its position. So anything that I'm circling right now in my final answer needs to end up in the reverse of where it is now. And by that I mean, if it's in the numerator, it needs to be in the denominator, because that's what I mean by taking the reciprocal of it. If it's in the denominator, in my final answer, it's going to end up in the numerator. So, to take the reciprocal of this, I'm going to flip, again, anything that's being raised to a negative exponent. So right now, it only looks like n squared is going to stay in the numerator. Everything else needs to shift. So in the numerator, I'm going to bring up 6 to the power of 1. That's now going to become positive. And then I'm going to bring up x to the power of 1 and y to the power of 4. So when I take the reciprocal of these, their new exponents will be positive. Now I need to bring down the 2 and the m into my denominator. So it's going to be 2 to the power of 1 over m squared. So remember, when I have negative exponents, I need to take the reciprocal. Now, I'm not quite finished yet. My final answer here, I can simplify two things. Or one thing, really. I can simplify my 6 and my 2. 6 divided by 2 is going to give me 3. So my final answer is going to look like this. 3n squared, x to the power of 1, y to the power of 4, all over m squared. If you want to put a 1 here to help you keep track of that 2, because 2 goes into 2 once and 2 goes into 6 3 times, if that'll help you keep track of it, that is fine. But this here is my final answer. If you have any questions, please ask a classmate in class or ask your teacher.